In today's session, we are going to focus on universal gates, NAND and NOR. So, in case of universal gates, why we are telling universal gates in the sense, so if you are using only one particular gate and if you are able to create other gates, then it is called as an universal gates. Okay. So in this scenario, NAND and NOR gates are called as universal gates because by using multiple NAND gates or multiple NOR gates, we can perform an operation of creating other NAND or other NOR or AND or XOR XNOR gates. And using NAND gates itself, we can create NOR gate, and using NOR gates, we can create NAND gates. So in case of shortage of the gates, or in case of creation of multiple gates using different gates using only one particular gate, then we can go on with uh, this particular option. So hence these two gates are called as universal gates. Why we are not preferring other gates are other gates is the size and the size and the results which we obtain is not that much feasible when compared to that of NAND and NOR. Hence, we are going on for this particular option of NAND and NOR gates. So when we are coming to digital electronics, realization is the major topic. In case of realization, it is the process of implementing or constructing desired logic function using a specific gate. So as we discussed already, using NAND or NOR gate, we can create other gates such as AND or NOT, NAND or NOR itself. So hence that process of construction or conversion is called as realization. It involves transforming a Boolean expression or truth table into an actual gate level circuit. So in this realization involves the process of physical implementation, optimization, use of universal gates, and design flexibility, testing and debugging. So in this case of physical implementation, we have to create a real world and working hardware circuits using this particular gates. Okay, so next one is optimization. So by utilizing the same data, same particular gate, we should not get, it should be cost effective, and this circuit diagram should be very efficient to get input as well as providing the output in terms of power consumption too. So it provides the minimization of gate utilization and power consumption. So when we are going for OR gate and gate, in that scenario what happens in the sense we will be consuming much more power, and the resource of utilizing the inputs and number of gates to be utilized will be very high when compared to these two gates. The use of universal gates, it is valuable very because it is cheaper, easier to fabricate and faster. So ICs often comes with NAND or NOR gate. So these days we are working with many high input gates, high input graphical cards, and many more terabytes of hardware. And in this case, we are in need of the output process should be very fast and do the graphical processing very faster. So hence we are utilizing universal gates. And in case of design flexibility, it is very convenient to translate complex logic functions. So hence it is applicable to all the real world scenarios and real world electronic devices. So in case of testing and debugging, it simulates, test and troubleshoots the function and provides a very effective result before the final deployment. So what makes a universal gate? The universal gate is a gate that can be alone. The term we have to focus is alone. It it is helpful in creating other gates such as and, or, and not. These are all basic gates. And or not are called as basic gates. Whereas in case of universal gates, we are going to create these basic logic gates using a single gate, single category of gate. If you are utilizing NAND, all the gate combinations will be of NAND alone. If you are going on for NOR, all the gate combinations will be of NOR alone. So why we are specific about NOR gate and a NAND gate? You can build NOT and or using only NAND or only NORs. So hence we are able to provide these combinations. So if the target gate is a NOT, NAND expression will be A and A. A will be input the same input will be NANDed with another A. And in case of target and, what we are trying to do is A and B. I want to get the, if you want to get the output, we are going on with A NAND B, A NAND B twice, and we are NANDing the output again, once again. So next point is A or B. So in case of OR condition, we are going on with A and NAND A, B NAND B, and we are NANDing with this one. So this is the difference between AND or NOR, AND or OR. So which particular input is given ANDed with another gate, another input. So next point is universal gates. Why not AND NOR or not universal gates? Why we are unable to create it as not, use not and or not or as a universal gate? Because not does the process of only inversion. It cannot create and or gates. Whereas when we going on for AND gate, what happens in the sense we cannot invert the process. So or there is no inversion. So these are all the drawbacks of the basic gates, and hence we are going on with NAND and NOR. So how is it possible with NAND or NOR? We can build NAND not and or gates only using NANDs or only using NORs, as we have specified in the previous slide, by the utilization of combinational logics. So this is the differentiation. This page gives the description on a differentiation between NAND versus NOR gate. Thank you.